I often enjoy watching Arjan Codes, a fellow YouTuber with generally good advice, but I was shocked recently to see a video of him tackling some legacy code. I mean, the design that he comes up with in the end is very nice, but the route he takes to get there, and in particular the tests that he writes, I think he's missing some important techniques. This is a kind of reaction video with a demo of how I would have written the tests for Arjan Codes' example, nested if/else nightmare. Hi, I'm Emily Bache. I'm a software developer, creator of Salman Coaching. Welcome to my channel. If you like what you see today, please hit like and of course subscribe for more content like this. If you're already a subscriber though, and you're looking for even more, I also have Patreon with additional benefits, and I'm very grateful to all of my supporters there. Now, this code is bad, and I totally agree that the if-else structure here is out of hand. And I agree with the rest of Arjan's analysis that the code gets this way over time through 1,000 tiny cuts. More and more logic just gets added until you end up with this kind of monster. I've seen this many times in my work as a technical coach. Every developer who added another if statement was just trying to get their task done. They were trying not to break anything, and so they could move quickly on to the next thing. This is not because people are lazy or wicked. This is just what tends to happen. Now, it's at this point that my views and Arjan's views start to diverge. He says, boringly, at this point you actually have to understand what is actually happening before you can start working on the code. And then he recommends writing detailed tests while reading the logic so you can externalize your understanding. Now, of course, I'm totally in favor of writing tests. What I disagree with is that you need to laboriously read and understand all of the code in order to do that. One time I worked with this team. They were based in Germany, and they had this really hairy C++ function. The logic was awfully complicated, much worse than this example. But this code was at the heart of their system, and people were scared to change it. There were no code comments, and all of the names of all the identifiers used abbreviated German. And I didn't understand anything, but using exactly this technique that I'm about to show you, we got this code under test, and then we were able to begin refactoring it with confidence. This is the code that I've got from Arjan's GitHub, and the original function approve order with the tangled logic we'd like to refactor. And here on the left, I've got the unit tests that he created. And these are actually very nice. I mean, if I run them, you can see there's lots of them with good names, and the structure of each individual test is really clear. And, actually I've got nothing against these tests, except they were a lot of work to create. He had to really read the code and understand it. I'm going to do a different thing, so I'm just going to start over from scratch with no tests. The other thing I found in Arjan's repo was this main function here, where he creates some suitable test data, calls this function, and then prints the result. So I can just run this to show you that it works, and it says that this order was approved. Now this practically is an approval test already, so I'm just going to take this and turn it into an approval test. The only thing I really need to do actually is change that print statement into approvaltests.verify. Now I can execute this. Now while the test is running, it pops up this diff window. This is normal behavior for an approval test. It's trying to check the result that it got against an approved file. There is no approved file, but it shows me the result that it got, and that's the same as I just saw on the command line. So that is the correct result, so I approve it. And then I can close this tool. The test in the background has obviously failed because the approved file didn't match the received file. There was no approved file, but now there is. So if I run it again, it passes. So that is a first approval test for this function. If I run it with coverage though, you'll see the problem. There's not much green here and a lot of red. We're not actually exercising most of this code. And before we're going to be able to change this, we're going to need a lot more test cases. But this is a good start. So in the process of writing that first test, I've learned a few things about the code. The starting point was actually very friendly. This main function already showed me how to call the code with some example data. In real code, it's often a lot more difficult to come by that. But if you can get a main function in place that executes your function and prints a string containing the results that you care about, you are well on your way. Next is the really clever part though. In order to get more coverage here, I'm going to want to vary some things. For example, at the moment, the user is a premium user, so we go into this branch of the code and we, of course, miss this branch. And it's same for quite a lot of different variables here. So what I'm going to do now is I'm going to go through all the variables I can see on the right-hand side that it's kind of changing its behavior based on, where it's in an if statement, and extract that as a variable on the left-hand side in my test. So I'm just going to go away and do that. I haven't got absolutely all of the things it's switching on, but I've got most of them. I'm also just going to move these all up to the start here. So I've got a list of the things I want to vary, then the part that actually constructs the test data, and then I've got the part that runs the function I want to run, and then I've got the bit for the result. I'm also going to extract that as a variable, and my tool is failing me, so let's do it by hand. This is exactly the same test case. It still passes in the same way as before and has the same coverage. But now I've rearranged the code sufficiently that I can extract this part as a function. When I use my tools to do that, you can see why I wanted to extract all of those variables. So this has got all the arguments are the variables that I extracted just now, and actually the return value is going to be that result summary that I also extracted. So this function needs a name, and I generally call this kind of function do and then the name of the function that it calls. So do approve order. It's not a test case, it's a kind of a help function, and it's got all the things it needs to actually run this this function that I'm trying to test with all these different variables that I want to be able to vary. So I'm just rearranging my code a bit so you can see that. All those things I want to vary are now arguments to this function. And again, this is just a refactoring of this test code. I haven't increased the coverage yet. Hopefully now, though, I can help to show you a better way to get that coverage that we want. I'm going to use another verify method in approval tests, and it's this one, verify all combinations with labeled input. So this function takes an argument. The first argument is a function, and this is a higher order function, so it wants the name of a function. And that's the one I just created. The next arguments to this are, it says star here in the help, which isn't terribly helpful. But basically what I'm going to put here is all of these named arguments. But not quite just that, I need to give them values as well. And each value of these needs to be a list. So for order amount, I need to have a list containing my order amount variable. And it's just the same for these other ones. So I'm just going to use a little trick with multiple cursors to insert lists for all the others as well. And now this actually is going to replace this bit of code here. So it's a different verify method, and this one does the work of calling this function with all these arguments. So when I run the test, actually it does fail. It wasn't a pure refactoring, but if you look more carefully at the output and I scroll to the right here, you can see the part at the far right here is the same as before. And this double arrow then, what's before that is all of those named arguments that I passed to my test function. So conceptually this does exactly the same thing. So I'm going to approve that. And then when I run the test again, it passes. So this section here, all I was doing was refactoring the original main function, basically, into this test case. There's one thing I forgot to do actually here. Another refactoring I want to do is just to inline all of these variables. I don't really need the separate variables now because the names are here in the named arguments. And by putting these actual values into these lists, it starts to become obvious that I can add more values to these lists in order to hit more lines of code. The first one I'm going to do actually is these booleans. It seems obvious that every time I've got a boolean, there are two valid values, and I can use both of those in all of these. So this time when I run the test, I get a different result. I have a lot more combinations of those input values in these tests. I've got loads more lines in my approved file, and the results that I'm getting are not always approved for the order approval. Some of them are rejected. So this looks good. It looks to me like I'm going to be able to hit more lines of code in my function just by adding all those booleans there. So let's check the coverage now. So it's updated the green and red lines, and I have more green lines. And I didn't basically need to expend any brain cycles to get that increased coverage. It was just noticing that, oh, some of the things I want to vary are booleans, and I could add the other boolean, and I've got more coverage. The next part, though, needs a little bit more thought, because some of these you don't actually really know what would be interesting values to include in the test. And for that, I am going to need to read the code a little bit. So, order amount. It seems to have a breakpoint here around 1,000. So let's put in a value below 1,000, since we already have a value above 1,000. And that doubles the number of combinations I'm testing. And that, I'm hoping, will also increase my coverage. So let's do that again. And this time, yeah, so I'm getting the other end of this else a little bit more. But there's still more work to do. So I'm just going to go away and see if I can think of some more values that I can put to increase my coverage. So I've now got at least 2 values for each of the things I wanted to vary, and I'm covering almost all of the function. I've just got an item here where the price needs to be below 0 to hit this line of code. So I'm doing very well, and a few lines here where I need to throw an exception. I could continue and add coverage for these last couple of cases in this function, or I could add additional ordinary unit tests for those. I'll leave that up to you. So what do you think? I've got really quite good test coverage. This is a good safety net for refactoring, and I didn't actually need to understand or analyze in any detail how the actual logic works. Writing tests like this becomes a fun puzzle more than a boring chore. Now, the tests themselves are using a lot of CPU cycles, since every time you add an item to one of those lists, you double the number of combinations. But the test is still fast enough to use for refactoring, and my brain cycles cost a lot more than CPU cycles these days. So next time you're faced with some difficult logic that you want to get under test and you need to refactor it, think about using this technique. Could you first create that main function, calling the logic, producing a string showing all of the results that you care about? Turn that into an approval test, and then use combination approvals to vary the inputs and cover all of the code branches, with very little additional test code. I think this is the way Arjan should have tackled his code. Maybe you can do better than him next time. Happy coding!